We put it a bit into a global context first of all, because the greenhouse gas emissions is not a straight line problem like target problem, as we see from the energy, from the government and from Paul Erik's slides just before. It's a cumulative problem, so it really matters when we are emitting the greenhouse gases. And if here in this map we just put some of IEA's scenarios and the carbon budget, remaining carbon budget, and these are from 2014, the budget from 14 and ahead. So this is what is left. And if you take the scenarios from, like, let's see, this is IEA's ETP below 2 degrees, so this is their most aggressive scenario. So with the chance, having a high chance staying below 2 degrees is almost gone. In this, but there are some chances here. This is the 50% or 33% of staying below 2 degrees. So they are below 2 degrees is actually, yeah, I would say a 2 degree scenario, and a 2 degree scenario is not a 2 degree scenario. It can't stay within the 2 degrees. But the Paris Agreement says that we have to try to reach 1.5 degrees. As Paul Erik just mentioned, it's going to be really hard, and we don't have many scenarios showing how that can be done. Translating that into Denmark, if we assume we can divide carbon budget, global carbon budget on a fair way, countries will never agree on that, but we have done it here, where we have used the population and emissions in 2011 as the keys for dividing it. I'm sure the developed countries will not find that a fair solution, but now that's something to discuss another time. So if we then take our projections of the energy agreement until 2050, then it's this yellow line, and that means here that budget staying below 2 degrees will be spent, and then and this is until 2050, and there still CO2 emissions in this scenario from 2050. That means so it's just getting. We are not staying below 2 degrees with the policies in place right now, and that. I think, sure, the government is also aware of that, because we have to look into that in the climate agreement coming up. But if we want to stay well below 2 degrees or to 1.5 degrees, you can see you have to really do something very fast. We can't wait until 250 to reach a zero emission. And that is also, and to look into these things, we have not only because of that, but we have built an energy system model called Times Decay together with the Energy Agency, and they're actually using it for projecting energy consumption for industry and households. We are using it for all sectors. And by having all sectors, we can also see what it takes to reach ambitious targets with this, and we can hopefully discuss also with government and parties about what to do and how fast. So I'll just jump to the homepage. This is just a screenshot, but this is our interpretation of the energy agreement, where you can see hopefully the same on the website. Now we're on the website, then I'll just move here. So actually our calculations are a bit more optimistic than the Energy Agency. They say 55%, we say with the policies in place, we believe in around 60% of renewables. And as of course, cost on wind and PV are going down still. But of course, it won't happen if there's not been put up enough tenders for wind parks and things like that. So there's a lot of barriers that had to be in an optimization model, and a model like this, it assumes that we solve the problem, but it just shows this is feasible with the technology. And we have all the policies implemented that Christopher was telling you about, all the taxes and support mechanisms and all this that is already in place. So here you see the CO2 emissions. So the policy so far until 250 or 230. So what is happening after 230 is just based on prices and technology cost and so on. So and they are still improving, so therefore it goes down. And you can see the problem is aviation, land transport and industry. They are the most expensive sectors to reduce CO2 from. Then we can see how much biofuel is used and things like that. But we can also say, okay, what if we have to go for a 2 degree or less scenario? Then using the carbon budget for Denmark, I just showed you, then if you look at the CO2 emissions here, then you have to the left is no, sorry, it's not the energy agreement. This was actually what they started with. So here's the energy agreement. It's not much difference. Because when they were discussing the energy agreement, we took the proposal from the government and compared to the different parties. You have the different parties here, so you can see what kind of policies they also have. But now we have the energy agreement, so let's stick to that. And then compare it with a 2 degree scenario. And this is a homepage, so you can go there and play around and see what you see and compare it and subtract it and so on. So what you can see is that you actually had to go much faster down, and instead of 60% renewable share in 2030, we should actually have something like 70%. This is because of the cumulative effect, of course, of emitting CO2. That you can't just go like this. You actually have to go like this to not spend all the budget too fast. If you're going like this, you spend the budget and you have to go negative. So, if some of you want to work with CCS technologies, there will be a good chance for that. I think if we are not making stronger plans than what we see already now. Yeah. So here you can also look at the transport sector. For instance, we were talking about electric vehicles. So we could just remove the carbon budget here. So what we see from what is there in the energy agreement, we still see some ICE cars, and that's probably also why the Climate Commission want to ban them, to get rid of them. Of course, we see electric cars and also some hybrid cars, but if we need to go for a 2 degree target, basically we switch to electric cars as fast as possible. And that is, of course, because of the good wind resources and so on in Denmark, so it is a clean transport solution in Denmark. And this is just, of course, the cars. And as also Paul said, for trucks and so on, it's different. There it can be used gas and biofuels and so on. But this is just to point out some of the challenges that it's not enough moving along a straight line to a target. We have to move faster, actually. And another reason for making this homepage was actually to get the models out of the black box. And because we think that energy scenarios and plans should be made in an open discussion with everyone, especially you who are interested in this. So we want to put this tool out there, and we are inviting all NGOs and parties and whoever who want to test some policies and so on. We can run it, and we can publish it on the homepage. And we will make a new homepage for the climate agreement, where we'll have more details on transport, buildings, and the industry. Then here we just have the most used. Actually, we have chosen these results from what we could see the politicians were discussing mainly. So trying to show that. But we know the discussions will go more into details in the climate agreement. So we want to also represent that because we have the details in the model, and our model is not perfect and not correct. And the good thing is that Danish Energy Association, they are calling us and say, hey, what is that? We can't understand these results. And say, okay, we have a look at it and say, okay, you're right, there was a problem there, and we change it. So that's also, so our scenarios are not static. We try to improve them all along. And right now we just found an error in the carbon budget we're using, so that's why I'm not showing the 1.5 degree scenario. So that will be ready next week. So yeah, so I guess that was all.